parallelogram. Okay. Math was not my strong point, but I'm guessing. Can I draw it on the board?
Yeah.
Let me show you what I think a parallelogram is. Math was not my strong point. That's why I teach social studies. But I believe it's something that goes like that. But I'm not sure how the numbers, but I would say something like, I'm just going to throw some numbers on here. You say it's like 4, 4, 6, 6. Parallel, parallel, same lengths.
A Monday warrior, mean strike. Today's Tom Sawyer, mean pride.
Answer the question.
Stop! You know how to find the perimeter of a parallelogram?
On a parallelogram, you just add up all the sides.
Cade, how are you?
I'm good.
Good.
Do you know how to find the area of a parallelogram?
I can fake it till I make it. What I think you do is you create a right angle going from the top of the parallelogram down, so you find the area of both triangles, and you find the area of the rectangle or square in the middle, and add together. So I believe there's a hypotenuse involved, right angles, triangular sort of situations.
Sounds good.
Fair enough? Yep. Parallelogram, right? One of these. Correct? True or false? You come down here, so you have triangle 1, triangle 2, then you have square this area. So what is it? Area equals 1/2 base times height for the triangle. Figure that out, figure that out. Length times width. That piece. Right? Makes sense to me.
So, Mr. Bow, do you know how to get the to find the area of a parallelogram?
I believe I do.
Okay, how?
I believe you multiply the length times the width.
Is this when I talk?
Yeah.
Look, it's a parallelogram. It's amazing. All right. We're going to talk about stuff. Check out the segment lengths, right? I made this little parallelogram and I cut it up so that we can take this little piece and move it over here, because now it's just a rectangle. So anything that's true about a rectangle is basically true about a parallelogram. So this side is equal or congruent, to use your geometrical term, to this side. And then the same is true here, because if it weren't, this would not work. Okay? So these sides, boom, boom, are the same, and these sides, boom, don't, are the same.
This man bears no more guilt than you. Who am I? 24601.
And now it's
Alright, now we're going to talk about the opposite angle measures. And here's how you can show that they're the same, because I really like this little thing that I cut up and made. So, you see this angle right here. If I take this side, which looks like it's the same angle, and I go and spin it with my fingers, right? And then I move it over here, also with my fingers. And I put it on top. See how they are the same? That is the magic of the parallelogram. So that angle is exactly the same. The same is true for the other angle as well. Otherwise, that also wouldn't work. So if I cut instead the other way and flipped it over, you would be able to see that too.
Then she bit me and punched me.
You know, the opposite segment relationship, they're parallel because it's called a parallelogram. Hey, let's talk about the angles and the ones that are consecutive. Alright, so if we move this back over here, you can see we've got 4 right angles. So what that means is that this is an obtuse version and that this is the acute version, and they're the same distance from that 90-degree angle. So however much less from 90 this is, it's this much more. So that means that these two would add up together to 180 because we basically have 2 right angles. Basically.